So again, welcome to today's webinar. We will be discussing data calculations in ARM, essentially kind of going popcorn style, left and right through the various transformations, the various calculations that are possible in ARM. We are going to try to move somewhat quick. Called this a refresher course because I think last year we took 2 hours worth of time to go through this. We split it up into a part one, part two, because I like to get long-winded, and especially when we're dealing with numbers and math, I'm kind of a math nerd, so it's even worse for me to keep it short and simple. But we are going to try to condense this back into one. So we're going to try to go pretty quick, knowing that if you do want to see something fast, slower, a little more detail, we can rely on those previous recordings that we did last year. So without further ado, let's just dive in. Kind of want to start just really with the basics, real briefly, in case you haven't utilized any calculations before in ARM. Essentially, we're really just very similar to like what you would do in Excel, as far as just creating a calculation or a transformational. Probably just keep switching in between those two words. Really just generating some new calculated information from a source assessment with that we took data as part of our trial. Now we want to process that in some way to generate ourselves new data to store in the trial. And so the really basics here would be to use the tools transform dialog. And it'll pop up that wizard that you see on the right, a whole list of different transformations that are available. And if you select the one that you want to use, then at the bottom of that screen, you would specify the source column number. What data do I want to pull into this calculation? And then also where to put the new values. Typically, you would do create a brand new column. So usually ARM defaults that number to whatever the next empty column is in your trial, is typically what's already put in there. Then once you click OK, you'll see the screenshot at the bottom. You get this brand new assessment column. And really a key difference is in the ARM action codes row in the header, there'll be a little code. So all of the different transformations that we offer really all are generated using that ARM action code. And we'll see today there even are more than just what's on that one dialog that you can utilize. So you can actually even take a shortcut, if you will, if you could go directly to the ARM action codes field in a brand new column, or you can generate calculations as well. So that's the real basics before we dive into kind of our host of different examples for us. First topic for us today is the control corrections. So depending on your research, quite a variety of different research will utilize the same general idea of wanting to calculate the efficacy of your products, your things you are testing, relative to the check, relative to the untreated treatment in the study. And so, efficacy is really calculating your percent reduction. So your check is always calculated as 0% relative to itself. We got nothing. And then all of the other treatments, what is the percent reduction? Did we eliminate the pest, prevent some sort of damage, things like that. So the Abbott's calculation here is really what we're looking for. Originally, kind of infestation assessment that's on the uniform population is what the tagline is, what the use for that Abbott's calculation is, but it is just this efficacy. It's a percent reduction, so it's used in a lot of different cases. The trick here and why we try to really go over this is there's a few different variations on this idea of how do you calculate this efficacy. just stemming from what what components you want to compare. So the kind of the default, the beginner level, I guess, if you will, is this first option, which was in my example, the last one with the regular Abbott's, we'll call it, which has the action code of TAB for transformation of Abbott's. And the idea with that calculation is you stay within the same replicate. So if I'm looking to calculate my percent efficacy of treatment 2, I would look in that one value in the calculation. I'm going to look for the check treatment in that same replicate 1 and do the percent reduction compared to just that check. And I do that, of course, for every value in my assessment column. So you end up with different values per plot. And that's the regular typical way you do things. The assumption is that your check treatment is reasonably consistent. Then this is just perfect for that. The gotcha is if your check is pretty variable across different replicates. You notice that you didn't get even pest pressure like you were hoping. So some replicates of the check are really bad and some not quite so much. Then you are a little concerned of biasing that calculation. So if that's the case, you could try to take the mean of the check across all the replicates and use that as your basis for calculating all of the other values for each treatment. So that way you're not swayed so much. The calculation isn't so swayed by your extreme replicate in the one or not very much pressure in the other. It gets just a little smoother, if you will. So you still are calculating different values for each plot. It's calculating by plot. It's just smoothing out that check a little bit if you do have a little more variation than you'd like in across your replicates. Then the last example is if it's really bad, if there's significant variation in across the whole trial, then you could take the mean of your treatment versus the mean of the check. So you end up not really having a different value at every plot, but it's just one for each treatment. And that also can just be a real nice summary, just an overall snapshot of your efficacy per treatment. And the key difference is just which action code you would select. So let's pop over to ARM quick to show that. I'm going to use my view options to make it a little easy to sort through this. I want to sort by my sort order for view and display as tabs. And this will allow me to kind of flip through different sections of our column. So I have an example here with column 1 being our source that we took, pest severity percent. And then I calculated an Abbott's, so that TAB. And real quick, how to do that: tools, transform, and I could choose Abbott's as the calculation that I would want. And down at the bottom, I can confirm column number 1 is indeed what I want to use for the source. Where should I put the data? And it's defaulted to the next open column. I'll just enter in 2, even though it's going to give me a warning that will replace data. That is the calculation I'm doing. So I'm not too worried about that. So there's that warning, and I'll say yes, because we're just repeating that same step. And what happens then, ARM replicates the description of what we had in our assessment, sometimes with small differences. So here, knowing that it's an Abbott, we change the rating unit to percent of the untreated check, since we know that's the Abbott's. And it'll distinguish the two of them, of course, if you were to do a summary. And this is really where that all comes from, is this ARM action code. It will calculate the Abbott's. Then if I did want to pivot to either one of those other calculations, we just talked about it, the Abbott relative to the mean of the untreated check, I could just change this to the U tab. And if I do that, it'll just ask me for which data column is my source. And of course, we want to do number 1. And it's going to eliminate the previous code, since you obviously can't do 2 different calculations. And now I have a different calculation that we end up with. So kind of the basics of how that would work, and changing codes if you need to, depending on that. Real quick, did want to show the APC. So those by treatment values, like I said, kind of just a nice reference sometime. And so we have a type of action code that starts with A. Usually that is an automatic. So it doesn't change any of your values. It's just instructions for when you generate a report. And that is going to generate those T-tab numbers, but only on the report. And I'll generate an AOV report just real quick to visualize that. In fact, I'll just preview it right here on the screen, and we'll zoom in a bunch. So column number 1, with that APC, we get to see the Abbott's values as percentages underneath our regular treatment means. So that's a use there, and you can compare that to treatment 2 with our Abbott's values. That's what we end up with, more or less. I'm not sure what I've done slightly different here. Oh, T-tab versus the Abbott's, right? So there are some subtle differences when you take the means compared to the raw values there. So it's not the exact same, but that general idea of bringing that percentage to an assessment already, you don't have to create a separate column if you're not going to do any analysis on that efficacy values. It's just there for reference. Okay, so that's the control. That's really the Abbott's and its variations. There are a couple of other control corrections that are possible. There is a Henderson-Tilton, and you can access that using the code THT, really designed for infestation ratings on a non-uniform population. Then you go out and take a pre-application before you apply the treatments. You go out and take an assessment. So you have a before and after. And so that calculation adjusts for that pre-count in order to get a slightly different efficacy evaluation there. And then Schneider or Relly, that one is when you're doing mortality, assuming that of course you have a uniform population. So those are other offerings depending on the type of research you're doing, that are all available in ARM. Another type of control correction is somewhat of the inverse of the efficacy, and it would be to calculate the percent of untreated. So really, when you're looking to evaluate the performance of your products relative to the check. So something when your assessment is a positive effect, if you're looking at yield, things like that, then you really want your check to be 100 as kind of the baseline, and then how much better did we make it with our product. And so pretty similar construct as far as slight variations in how you can go about this, very similar to what we had with Abbott. So we kind of structured the slides here. So much like the Abbotts, we have the comparison relative to the check within my same replicate. So every plot has its own value. If you can assume the check is pretty consistent, that's your best bet. And so this one, you would use the code at UPOC, percent of check. Then if you don't quite have that consistency in your check, we really don't have a middle option for the percent of untreated. We kind of drop down to the bottom where you just take the mean of your treatment versus the mean of the check. So now you're going to get a per treatment value if you use the TUPOC. Same idea as what we talked about with tab versus the T-tab. And also there's an automatic, so APOC, if you want those percentage values in your report, but you don't want to create a separate column. I don't think I have an example there. It's very similar in structure. Yep, so we'll move on to the next one here. Next type is subsamples. If your assessments are based around subsamples, there's few different ways you can summarize those subsample ratings. If you want to create a calculation, create a summary, if you will, from those subsamples. You can do very basic, average, or sum with subsamples. Maybe a little more interesting of a calculation would be incidence. And it just depends on which is your percentage, the percentage of the subsample values in a given plot that are larger than nothing. Of course, it depends with your rating, you might have a slightly different definition of nothing or the lowest. So, nothing could be 0 if you're doing counts, things like that. Anything above 0 is the presence of what you're rating. So you would use TIO for that calculation. If you're doing a rating scale, which we'll get to a little later, we've got more calculations with rating scales, but something like a rating scale where 1 is the lowest, which means there was no, whatever you're looking at, no damage or something, then 1 would be your nothing. And so you would use TII for calculating incidence from that. And if you need kind of a more custom calculation, you can count up the number of subsample values within a certain range. So if there's some other way you want to classify, maybe you have different groups, classifications that you'd want to group together and count how many were from 10% to 50% or whatever. You can kind of create some custom ranges that way with TIN. Big thing is here, this summarizing, you typically don't need to create a separate column if you're just thinking about analysis, because by default with the ARM analysis, we don't analyze subsamples. So by default, the very first step in the analysis portion is to average out your subsamples. So if that's the only purpose for some of those first ones, you might not really need to create a separate column. Just real quick, won't spend much time on it, but I'll just toggle over in ARM to my subsample example. So here I have 5 different subsamples in my assessment. And then I used TIO to give me the percentage of subsample values that were larger than 0. So if I look just at this first plot, I can see 1 out of the 5 were 0. So only 20% didn't have whatever it was I was rating. So our incidence is 80%. Then I also counted up. So this is going to calculate from column 3, all of the values between 50 and 100. How many subsamples in each plot fit in that range? And of course, I've got 2 50s, so we end up with 2 there, even though the next plot didn't have any. So that's how the subsamples how you can kind of summarize your subsample assessments. All right, next topic. We just kind of hinted at the rating scales. So EPPO has a whole set of standard scales, but really usually focusing on both a pest and crop combination. There is a scale. And the general layout of all of those scales is that they are 1 to some number. We'll say n. So 1 is your no incidence. And I just have a couple on the screen here just as examples, showing again, often it is targeting one particular pest or a type of pest, and then one specific crop as well. So, blue mold of tobacco when you're evaluating fungicides, the one on the right. And so 1 is always the 0 level, and then they've tried to just scale based on a variety of factors, scale the rest of those values, in this case 1 to 5 or 1 to 4, appropriately. Makes it easier for an assessment because now you're categorizing instead of asking a person to be as precise as, what's the difference between 10% and 15%. I need you to have a number, a very specific percentage number compared to a range. Oh, this is a 3, this is a 5. Little easier to do, maybe a little more consistent. That's the general setup here for these types of assessments. And so there are different calculations in ARM that we can do with these values. But first, kind of want to show how to set them up, how to enter in these ratings. So if we want to use the calculations tied to these EPPO scales, this would be kind of how you would fill out your ARM trial. You would create for this one assessment that you would perform, you would create multiple assessment columns, one for each class or level that you have. So I'm going to use that 1 to 4 rating scale as our example. So 1, 2, 3, 4, we've got 4 different categories, 4 different levels that we could get. So we create 4 columns in ARM. And what we are recording then in the cell is how many subsample values, however many of our samples fit into that category. So reading across on the bottom here, for this one assessment, we had 5 of our samples were category 1, no incidence at all. 2 of those samples fit into, we give them a rating of 2. 0 of them had a rating of 3. Oops. And 2 of them had a rating of 4. So that's the way to fill in ARM so that we can use some of these calculations here. So again, assuming we've kind of created a separate column for each class, then we can calculate an incidence and a severity or an index from those columns. So first is the incidence. That's the percent of the subsamples that had the presence of the pest. So anything, basically the percentage of how many samples weren't number 1. And what you do then is, here my example, DIP is the code here, 1 to 4, depending on which scale you're using, you specify that. And the column number you put in here is the column for class number 1. So I'm going to go back one screen here just to show that we started in column 10. And ARM will then know, because we've structured this in this precise way, it'll start with number 10, and it knows that 11 is the 2s, 12 is the 3s, and 13 is the 4s, because we've done this consistently. So that's kind of why there's the whole manual here of getting the data set up in this particular way, is that is how the calculation is coded. So to calculate your percent incidence, we would use that code. Then you can also calculate your severity. So, the percent is just what was untouched. Severity tries to take into account how large the magnitude of that, whatever we were rating, if it's the disease amount, or if it's how bad the phytotoxicity, whatever it was, we're trying to account for that in intensity, and that's the EC14. I'll toggle to ARM just really quickly. It's pretty much the exact same thing as in my screenshot, though, where I've done that leaf damage category 1, 2, 3, and 4. So we have just the counts. We had a total of 10 subsample values. I guess I should have filled in my sample size to be a little more descriptive. 10 subsamples total. I think what 4, 2, and maybe not. Maybe they get. In theory, these should all add up to the same number, right, in each row. But maybe I faked it too poorly, perhaps. But at any rate, then you would have your damage. I go down here. The pest severity and pest incidence have the two slightly different action codes that you would utilize. And so, because there's so many different combinations, 1 to 4 versus 1 to 5 versus 1 to 7, we don't have these in the transform dialog. Instead, you would utilize the action codes, and there's a whole grouping. If you look at there's kind of these grouping rows to see all the EPPO rating scales. They're all grouped together in this list. So that's kind of the particulars for the EPPO rating scales. Of course, isn't the only type of rating scale that can be done. So if you are using a 0 to some number rating scale, we do have calculations for those as well. So less specific setup, and I think maybe a little easier to enter because you can, instead of creating all those different count columns, you can fit everything into one assessment column. So for these examples, you can just one column and put in subsamples. So here, 10 subsamples. I can have the 10 slots for each one of my samples per plot, and I can just enter the rating. This one's a 0, this one's a 2, this one's a 1. You just go down and put in the rating you would give each of those samples. Then we can generate the very same type of calculations as far as incidence goes. What percentage are not 0? Calculate the severity. How bad is it in the ones that did have that, the presence of whatever we were looking at. And then there is a Townsend-Huberger, which is just a slight variation on the severity to really convert it into a percentage. So it really takes kind of it takes that severity calculation and then turns it into a percentage. So if you had the very worst rating in every single subsample, it would be a 100%. If you had zeros in every subsample, it would be 0%, and then it just scales according to that. So those little easier to enter, I guess, in some regards, easier to put into ARM. If we switch over to my scale grouping, Oh, somehow I didn't put in any values here. But being able to put everything into one column, just from an overall screen space standpoint, at least, it's maybe easier. So I've got 0 to 3, so I guess I should put in some values here. Very scientific as we can see. But then it'll start to calculate those percentages of incidence, severity, and that I think this last one is that Townsend-Huberger. Yep, as a percent severity. Any questions on these rating scales? Like I said, I've been going real fast. You can always rely on our previous recordings for a little bit slower talk through some of this stuff. All right. Let's move on to the next category, which is actually pretty open-ended in its possibilities, and it is the user formulas. So basically think of Excel here, where you just type the equal sign in some cell and you just come up with something you want to do with various other data. Combine them, add them together, multiply them, whatever it is under the sun. Hopefully, probably, possibly, we can do that as well. So you would just use that tools transform dialog once again, but about halfway down, you would toggle on the user formula instead. So, okay, I want to enter something instead of using these baked in ones. Few different rules and ways that things you need to follow in order for ARM to understand what you are trying to achieve. First and foremost, if you're wanting to take existing data, which of course you are, that's the whole idea, you would use brackets to refer to the data in a particular column. So my example, if I just wanted to add the data from column 1 and column 2 together into column 3, bracket 1 plus bracket 2, that's going to put together that data. There are quite a variety of different functions, very similar to Excel, when you can find some function that'll do a little more sophisticated processing of data. We do have quite a few of those. Let me show in ARM kind of how to find that. Let me toggle over to the user formula real quick, and we'll just use column 18 as our source. So if I use tools transform, like I said, about halfway down on the dialog, there's the user formula toggle. And that just kind of hides all of those other options and just gives us that equation bar that we can type things in. And there's a little bit of help text to kind of help point out things you can do. My go-to is to click on the help button down in this corner. And that'll bring up our help system here. Looks like I need to size it properly. And these buttons are everywhere in ARM. Whatever screen you're looking at, it'll bring up a topic showing you all the different options and buttons that are on that particular screen that you're looking at. And you can read up on what all of them do. So we've got write up on all those different transformations that we have available, but I always scooch down to the link to the user formula. And clicking on that user formula link takes me to the topic specific to creating my own calculations. And there is a nice write-up here to show all the different things you can do. Like I said, we don't have time to go through every one of these. We'll hit the highlights of things that are most useful. But there's a lot of more tips and tricks within this dialogue here, or this help topic, telling you what, formulas, what mathematical equations you can use, but down here are those functions I mentioned. So you can do things like average and count. You could even do, subsamples, average across subsamples, sum across replicates, a variety of different things that you can do. Most all of them use this little at symbol to signify that it's a function, right? It's a special code that ARM recognizes that will then use different information. So this is kind of the real handy help topic to utilize for the data transformation formula. If you want to figure out, can I do this particular thing? Oh, yep. And let me go back to ARM to show the couple more options that are underneath this user formula, but still on this dialog. A couple of options if you want to limit the values that we're calculating, limit those to positive. Yeah. Essentially truncating anything that would come out to be a negative value and truncating it to 0. In certain cases, if you're doing the difference, relative to the check or a reference product or something, sometimes it really doesn't make sense in the real world that you would have a negative performance. You would just kind of cap the floor at 0. If that's the case, you would turn on this option. I think it kind of just depends on what you're doing, whether that would be important or not. Then if you are dealing with subsamples and you want the calculation to result in just one value, you would turn on this option. And that just kind of collapses, as far as the equation goes, and make sure to summarize down to just one value. So those are the two options there on the transformation dialog. And probably one thing from that help topic worth mentioning, that's probably fairly common. If you do want to calculate relative to the check, or at least just refer to something like your untreated treatment, you can use the TU component. So in this example, take the data in column 1, divide by specifically the data in column 1 associated with the check treatment, and then multiply by 100. So we're doing kind of a percent of the check. Don't know what I keep bumping here to move the slides. I apologize here. So those are kind of the basic entry level, creating your own formula. As I hinted at with that help topic, you can get pretty deep. You can get pretty involved. Fairly sophisticated types of calculations can be done. If you're just starting out, just don't worry. I think there's a good majority of things you'd want to do that are simple and easy to calculate, but just know that there's a lot under the hood that is possible. So I won't really go into all of these right now, but certainly if you have a need, have a requirement, wish you could calculate something, or maybe you already are in Excel, and you're just like, oh, well, it sure would be nice if ARM could do it. So then I don't have to like paste it into ARM or something. Just send us an email. We can kind of help step through what your calculation is. And I've got pretty good confidence that there's some way we can build it so ARM can calculate for you. And the power, especially with something like that, is if you can create it once in ARM, then you can save that calculation along with the description of that assessment into an SE. And now every trial that you do that you want that calculation, the formula is saved in an SE, a standard evaluation. So you can again and again generate that formula, that calculation in all of your other trials pretty seamlessly because that information is saved in your SE. So you're not having to remember and memorize all of these different formulas. Okay. Oh, actually, before we move on, let me switch to ARM just real quick to show the one aspect of these user formulas that once you've created one, and let me look at column 19 here. I have a calculated column. So if I go back to tools transform, which is one question we get often is, hey, somebody created their own formula. How do I know what they did? This is one way to do so. So I've got a calculate column. I'm not sure what they did. You'll notice that in the ARM action codes, it just says T1 or T4. That's kind of our generic description linking a user-defined transformation formula. So ARM remembers trial by trial, which transformations were created in this one trial. So to see what was actually done, if I click somewhere in that calculated column, and then I do tools transform, ARM will fill in and show me in that user formula what that person entered. So now I know how they created this column 19 is they took the data from column 18 and multiplied by 2. Pretty boring, not very exciting, but hey, now we know that's what happened. And in fact, if I want to see all of the equations, there is a drop down here. So for this given trial, I've actually had 4 different formulas that I've generated. And so you can see all 4 of them here. Little hard, I don't exactly know where each of these are at. So I kind of like to do the first option there, but I can see this T4 since we're looking at it in column 29. T4 took the sum of column 18 and 19 and added them together. And sure enough, that's exactly what we ended up with our numbers. So very rudimentary, very boring examples, but just to show kind of how that works. And the slight difference, kind of the one gotcha there, is the action code, kind of a placeholder for the actual formula itself, which gets typed in here instead. Okay, now let's go back. Just a couple more topics here. The next type of calculation is yield conversion. So quite common, of course, would be at the end of the season to harvest your crop, and so you have the kind of the raw yield values that were recorded, wanting to adjust those, of course, to a per area basis. A lot easier to summarize and talk about those values, per hectare, per acre, how much the plots yielded, as opposed to, oh, well, this was my yield, but yeah, I'm in a 5x20 plot versus whatever. Just wouldn't make any sense, right? Very hard to compare. So ARM has a built-in conversion tool, so you can specify the parameters for the data that you took and how you want to convert it. So I've kind of highlighted here on the screen, this is under Tools, Convert Yield. This is the dialog that pops up. So the first thing you would do in the units would be, what did I record? What is my raw data in? If it's in kilograms for my yield, then what do I want to convert to? So I want to create a new column and convert it to tons per hectare. That'll set up kind of the initial conversion, right? But just based on my plot sizes, I can kind of calculate a conversion amount. And you'll see that when you're using that dialog over here next to this red arrow, the conversion factor. It'll calculate based on those 2 units, what would I need to multiply by each of my values to land at tons per hectare instead. Few different functions though, as it may be a little more complicated. You can adjust for moisture. So if you have another assessment column with moisture values, you can bring that in to use that data column number as your moisture at harvest. Or if you simply just have an average across the whole trial, you can just type that value in instead. And of course, this first value is what dry moisture percent are you trying to adjust to? There's also the ability to define specifically what your harvested plot size is. Maybe you don't harvest the entire treated area, which is kind of the default plot size in ARM. When you're setting up the trial, you say what your treated plot size is because you need that for your product amounts and such. But maybe what I harvest is smaller or larger. You would never be larger. So you can tweak that amount. So your width and length are auto-filled from the trial settings, but then you could manually change them, right? Maybe I cut my width in half because we only harvest the 2 middle rows and leave the outside rows be. Or even more complicated if you had varying sizes for each plot, or maybe there's just a couple plots that you just had to stop short so they weren't the same size. You can create an assessment column and fill in the widths and or the lengths as well if you needed to be that we'll call it sophisticated of a calculation to get the yield conversion just right. You can do that as well. So kind of 3 different components here to fill in just depending on the given situation. And in the end, then that creates a yield calculation. Just like the other transformations, you point ARM to the column with the raw yield amounts, then specify what column number you want to create that in. If I go back to ARM to see our yield examples, wish I had a little bit more screen space, but we'll make do. There's my test weight, my moisture percent. So those are the 2 sources from my combine, perhaps. Then I can create, if I go back down, we can see this TY with a number. That would be a yield transformation. So kind of similar to the user defined, we just kind of keep track of when you use that yield conversion formula, keep track of what was calculated. The yield is a little trickier. So if I try to do this tools convert yield, we can't always reverse engineer this dialog quite like we did with the transformation. Just because these different components can be different. So it's not quite as straightforward to regenerate the dialogue, kind of like what we did the user formula. So that is a question that we run into every once in a while if the trialist is the one that creates that conversion. You can always create a separate column and like compare the numbers to make sure they're the same, something like that if you wanted to double check what was done. And it looks like I just, for whatever reason, I have a percent of untreated calculation as well, falling back to our percent efficacy if we wanted to show that as well. So that's the yield conversion component as well. And this one is a little different in terms of replicating it in different studies. Not really recommended to include as an SE, at least using that dialogue, because, as we said, there's all of these slightly different things, right? There's your width and your length. Probably can't guarantee it's always the same plot size anytime you use that SE. So it's a little bit different, a little bit specialized relative to a lot of these other equations. I want to do that function all of the time. The yield has these different inputs that can just be subtle but different. So it's kind of best to always just use this wizard each time. Right. Last but not least, last example for us is area under curve. So the general setup here would be if you have repeated assessments, go out and perform some type of assessment at hopefully a somewhat standard interval. Maybe every week I need to go out and see how our pest is progressing or being controlled. And so I have the same assessment over the course of time. And then that becomes the question at any point, any snapshot in time, I can run an analysis based on that column of data. But what about the whole duration of time? How did things progress across time? So to answer that, there's some different tools that you can use. And this example specifically is a calculation that's trying to capture that idea of how bad or how good was it over the course of all of this time. So we're really going to total up all of the responses across our time interval of those repeated assessments, but weight those values according to time. So probably the most common, perhaps, example would be your AUDPC, your area under disease progress curve. But it's generalized. It doesn't have to be disease. It could be any type of assessment, really, that has this duration to it. And so a more general term would be area under curve that we use. And the idea, if you want to brush a little geometry off, is if we were to plot out each treatment, the response across time, we really, to create a weighted amount, pretty much we calculate the area, right? The area between each of these points. Shade that all in, that area gives you this weight to it. If it's really high for a really long time, like this green has a pretty high response, if that's good or bad, let's say it's bad, we didn't do a good job controlling anything the pest was getting out of control, then for this duration here in the middle, it really struggled, although towards the end it got better. We want to weigh that in. So having this higher area gives more weight to that problematic time frame. So that's kind of the general idea. And in ARM, I've got the example here. So disease count, fairly regular intervals, looks like every couple of weeks across the course of the season, we went out and did our count. So then what we can do, I've got this AUDPC calculation then that we have defined. And really the number itself doesn't matter, right? It's all kind of totaling the amount there. 2,000 isn't significant in and of itself. It's all just the comparison between the other treatments is really the idea. And just to show how that gets created, if I click in really any one of these assessments that are involved in my series, I can Tools Transform and choose the area under curve. And we'll start with column 22, but we'll actually end up selecting more than that. And then we'll put it into a brand new column. That's fine. But when I click OK, there's actually a wizard that'll come up to help us find the repeated assessment. So ARM takes that column, the description of column 22 that I started in, and tries to guess at what the repeated assessment would be. So assuming the same rating type and the same rating unit, that's a good place to start. It can also consider crop or pest if we're looking at different pests. And so it decided, well, it looks like there's a pattern of disease count percent with this particular pest gives us 4 different columns, 22 through 26, which it's hard to see because my screen is a little small, but it has selected those automatically, which is that set of assessments we did again and again. I can tweak this if I need to. There's little filter boxes. I can adjust what it finds if I need to, but hopefully the assessments were entered consistently so it can find them all. And then it creates that calculation, which, like I said, the number itself, not really important. You would never say, oh, well, this treatment achieved an AUDPC of about 1,200. That doesn't mean really anything itself. It's run the ANOVA and do a mean separation to see, did time play a factor? This time was significant or it wasn't, depending on your data. We also have, just as a small bullet point, there's also a repeated measures type of analysis. Very similar idea as far as the construct of multiple assessments, just kind of different world as far as what it does. It essentially sets up a split plot factorial design and runs the factorial analysis on those different columns. Not much time to dive in further, but that would be another thing you could look at for those repeat assessments and how to analyze and factor in time across the duration of those assessments. All right, well, that is the last topic. So we made it to the end without too much overflow. Like I mentioned, did go pretty quickly. If you want to circle back and see some of this a little slower, we did cover all of these topics last year. So in our 2024 webinar archives, you can check out basically all of this info, but in a 2-hour session instead, if you want to see them slower, or if you have questions, if you have a need to calculate something, but you're not quite sure what levers to pull, as always, you can let us know through our email. So thanks everyone for your time, and hopefully we'll be seeing you at a future webinar soon.